Hi there, this is the Aptitude Guy. Welcome to another lesson video on quantitative aptitude. In this video, we are going to learn about the topic of units place. This is a subtopic of number systems, and the concept we'll be learning today will be cyclicity or power cycles. Alright, this is part 1 of units place. So without any further ado, let's get started. And of course, if at all this topic has always been a pain point for you, if you know that, then I would urge you to like this video so that this video always stays in your liked videos folder of YouTube app, so that whenever you need to rewatch it or reuse it or revise it, you always have it handy. Having said that, let's get started. Now, when it comes to units place, okay, first let's talk about units place, how to find the units place. I'll start with a very simple example. Suppose I give you 12 plus 13. What is the units place of the sum? 12 plus 13 is 25. So the units place is 5. Now let's take it a notch higher. Suppose I give you 12 multiplied by 13. What is 12 multiplied by 13? 12 into 12 is 144 plus 12 is 156. So it is 156. So what is the units place here? 6. But if at all there is a question like this, 123 into 456, then is it very easy to find the units place like this? No. So let me give you a trick to getting the answer. Some of you might already know this, some of you might not. So listen up. Since we only need to find the units place, right? So we only need to care about the units places here. Simply 2 plus 3. 2 plus 3 is 5. So the answer is 5. Now over here we have multiplication. What is 2 multiplied by 3? 2 3s are 6. So we have 6 as the answer. So similarly, what will be answer in this case? 1, 2, 3 into 4, 5, 6. 3 multiplied by 6, that is equal to 18. And what does that end with? That ends with 8. So this number could be a 5-digit or a 6-digit number, the product. We don't know what that number is, but we are 100% sure that that number has to end with an 8. Similarly, if at all we have an even bigger number, that is 1, 2, 3 into 4, 5, 6 into 7, 8, 9. Pause the video and figure out the units place over here. It will simply be 3 into 6 into 9. 3 into 6 into 9 is how much? 3 6 are 18, so that is 8. 8 9s are 72, that is 2. Or you can do it in any order. Do it the reverse. 6 9s are 54, and then 4 3s are 12. That also ends with 2. Or you can do 3 9s are 27. 7 6 are 42. That also ends with 2. So whatever that product is, it will 100% end with 2. Now, what if I replace this multiplication sign with an addition sign? Then the same thing will happen here as well. We have 3 6 9, and this will turn out to be addition. Now according to BODMAS, first we deal with multiplication here. 3 6 are 18, that ends with 8 plus 9. 8 plus 9 is 17, so the units place will be 7. That's it. This is how units places are found. But when it comes to the aptitude test of companies and placements and competitive exams, the questions will not be that simple. The questions will look like this. 123 to the power 456 into 789 to the power, say, 123, and then we have 456 to the power 789. This is the kind of questions that we will get. Alright, now how do we solve such questions? It looks like an insane number. Of course it is an insane number. This entire thing, if you calculate, your calculator first of all will give up. And this entire thing will be around 10,000 digits long perhaps. And we have to find the last digit of that number. Trust me, if it seems intimidating to you, don't worry. Watch this entire video and I promise you, you will be able to figure this question out. Alright, so now Let us start with the concept. In order to solve such questions, the first thing you need to know is cyclicity or power cycles. What do you mean by power cycles? Let's take for example 2. What is 2 power 1? 2 power 1 is 2. What is 2 power 2? 2 power 2 is 4. 2 power 3 is 8. 2 power 4 is 6. This is the power cycle of 2. Now, why is it called a power cycle? First of all, power because 1, 2, 3, 4. Power 1, power 2, power 3, power 4. So that takes care of the power part. Now, why is it called power cycle? Where's the cycle? The cycle is because it keeps repeating the same way. 2486, 2486, 2486, 2486, 2486. I'll prove it to you. 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16. That ends with 6. Okay. Then after 16, 2 power 5, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8192, so on and so forth. It goes on and on and on and on and on. That is why it's called the power cycle of 2, 2486. Okay. Similarly, pause the video and try to figure out the power cycle of 3. If at all you got these 4 numbers, you are absolutely right. We have 3971. And again, it goes on and on and on. 3971, 3971, 3971, 3971 all the time. Similarly, let's find the power cycle of 7. Now the problem over here is this. 7 power 1, 7. 7 power 2, 49. So 9. Till here everybody knows. But after that people start getting doubts because then we have to find 7 power 3 and then we have to find 7 power 4. Now 3 power 3 is 27, so we have 7. 3 power 4 is nothing but 9 square, which is 81, so it ends with 1. That part was okay. But why would you remember 7 power 3 and 7 power 4? Only math teachers remember that. Nobody else has to. Where would you use 7 power 3, 7 power 4 in real life? Nowhere. So, how do you figure this out without actually remembering what is 7 power 3 and 7 power 4? Let me show you a little trick over here. Alright? Please concentrate. Now, let's go back to 2's power cycle. 2 into 2 is 4. 4 into 2 is 8. 8 into 2 is 16. So that is 6. This part is pretty obvious, right? Now, be prepared to be mind blown. 3 into 3 is 9. 9 into 3 is 27. Till here all okay? Till here everything makes sense? Now, 7 into 3 is 21. Now you know and I know that this 1 actually came from 3 to the power 4, which is 81. But the one coming from 81 or the one coming from 7 threes are 21. 1 is 1. Why should we care where the 1 came from? We only care about the 1. 81's 1 or 21's 1. 1 is 1. Simple, right? Into 3, into 3, into 3. Now the same thing will apply to 7. 7 sevens are 49. So we have 9. Till here all obvious. After that, 9 sevens are, we have 63. So this ends with 3. Now actually speaking, this 3 actually came from 7 power 3. What is 7 power 3? 7 power 3 is actually 343. But the 3 coming from 343 or the 3 coming from 63, why should we care? 3 is 3. We only care about the units place, right? Now next step, 3 sevens are. 3 sevens are 21. So this will be 1. Actually speaking, this one is from 7 power 4. You can find out what is 7 power 4 using the calculator. That will end with 1. It is 2401. Now the one coming from 2401 or the one coming from 3 sevens are 21. 1 is 1. That's it. Nobody is going to ask you how you got that 1. So this is 7's power cycle. Now that you know this little trick, try to figure out the power cycle of 8. Now you will be able to figure it out, not a problem at all. If you got these 4 numbers, you are absolutely right. Let's apply the trick here as well. 8 8s are 64, obviously. 4 8s are 32. And 2 8s are 16, so 6. But actually, what are these numbers? 8 power 1 is 8, 8 power 2 is 64, 8 power 3 is 512, and 8 power 4 is 4096. But do we care about those big numbers? Absolutely not. This is all that we have. And this is the simple trick to get to this power cycle every single time without memorizing anything. Please don't depend on your memory. Use common sense as much as possible. Now, the good news is these are the only four numbers whose power cycles have four terms. Okay, everything else is much easier than this. For example, there are two digits whose power cycle has only two terms. Can you guess what those two digits are? They are 4 and 9. That's it. Let's check it out. 4 power 1 is 4, 4 power 2 is 16. Then 4 power 3 is 64, and so on and so forth. Or another way to look at it, 4 fours are 16. Then 4 6 are 24. Then 4 fours are again 16. 4 6 are 24. 4 fours are 16. 4 6 are 24. It goes on and on and on and on. Same thing with 9. 9 nines are 81. Then 9 ones are 9. Then 9 nines are 81. 9 ones are 9. 9 nines are 81. 9 ones are 9. 9 1 9 1 9 1 9 1 9. Now this gives rise to a beautiful conclusion. Since the power cycle has only two terms, we don't really care much about the power. We only care if the power is odd or even. For example, if at all you have a number ending with 4 and the power of that number is an odd number, then the units place of that expression is 4. But if at all the power is an even number, then the units place is 6. Okay. For example, we have 4 to the power 123. 123 is an odd number. So 4 to the power odd number ends with 4. But if at all we have 4 to the power 1, 2, 3, 4. Now it's an even number. So 4 to the power even number ends with 6. And it doesn't matter what comes before 4. You can have 2, 3, 4 to the power 2, 3, 4 or 1, 2, 3, 4. The answer stays the same. Not an issue. Same property with 9 also. 9 to the power odd number ends with 9. 9 to the power even number ends with 1. So if at all you have 7, 8, 9 to the power 7, 8, 9. What do you have here? 9 to the power odd number ends with 9. But if at all you have 7, 8, 9, 0. Now 9 to the power even number ends with 1. That's it. Now every other digit that you can think of, that is the best place to be over here. For example, these four digits. This means that 0 to the power anything ends with 0. 1 to the power anything ends with 1. 5 to the power anything ends with 5. 6 to the power anything ends with 6. So if at all you get these four digits in the question, the first thing you should do is get a big smile on your face. But unfortunately, since these four digits are so simple, you rarely get these digits in the questions. Alright, now how to use these power cycles in the questions, that we will learn now. But if at all you have any doubts in the power cycle part over here, definitely drop them in the comments. I will try to answer every single one. Alright, now let's apply this beauty into questions. This is question number 1. It has 4 sub-questions ranging from the simplest difficulty level to the slightly tough ones. Alright, let's go step by step. What is the last digit of the following expressions? Okay, cool. Now the first thing we do is we check the base value. The base value is 2 for all of them. Let us first write the power cycle of the number 2. 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16, ends with 6. This is the power cycle of 2. Alright, now let's solve the questions. We have 2 to the power 5. For this we don't even need the power cycle. We know 2 to the power 5 is 32, and what does that end with? That ends with 2. Done. Now we have 2 to the power 35. That is a huge number. For this, we will need the power cycle. Now let's see how do we use the power cycle over here. First of all, let us first try out 2 to the power 5 with the power cycle, since it's a very easy thing and we absolutely know that the answer is 2. Let's try this out. We have 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. 5 is 2. Alright, so this is how power cycle works, right? Now we have to go all the way till 35. Now a lot of people think that 2 to the power 35 will also end with 2. Because what they do is they take 2 and then they take the units place of the power also, which is 5. So they think 2 to the power 35 is equal to 2 to the power 5, which is equal to 2. But that unfortunately is the wrong answer. I'll prove it to you. We have 2 to the power 1, 2 to the power 2, 3, 4, 5, right? Let's carry on all the way till 35. We have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Where did 35 end? At 8. So 2 to the power 35 actually ends with 8. That is the answer. Now, if at all this question is given in the exam, will you sit and count? I mean, you can. For 35, you can count till 35. But if the question is 2 to the power 125, will you sit and count till 125? If the question says 1234, will you sit and count till 1234? Absolutely not. So there has to be an easier and a quicker and a faster way to do this, right? The quicker way to do this goes like this. Since the power cycle repeats after every 4 terms, this is what we do. We have the power, which is 35, and then it repeats after every 4 terms, right? So then we divide this by 4 and we get the remainder. This will tell us how many remaining counts are there after the finish of every power cycle. I'll give you a simple example to make you understand what this is. See, when we talk about the days of the week, what all do we have? We have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. We have 7 days in a week. Now, if at all I tell you that today is, say, Monday, what comes 7 days later? We know that the week repeats every 7 days. So, Monday plus 7 days is again Monday. Now, what is Monday plus 14 days? Obviously Monday. What is Monday plus 21 days? Again Monday. What is Monday plus 70 days? Again Monday. What is Monday plus 777 days? Again Monday. Why are we getting Monday every single time? Because all these numbers are multiples of 7. That means when we divide 777 by 7, what is the remainder? The remainder is 0. So if at all the week goes ahead by 7 days, it comes back to the same day because the week repeats every 7 days. That is why we are dividing by 7. Now this power cycle is an example of a week which has only 4 days. That's it. That is all that it means. So for a week, we divided by 7. For the power cycle, we divided by 4. Okay, I hope that makes it clear for you now. So we have 35 divided by 4 and we get the remainder to find the number of extra numbers. So 35 by 4, what is the remainder? We know that 32 is divisible by 4, right? So if 32 is divisible by 4, we have 35 by 4. 4 eights are 32. The remainder is 3. Now when the remainder is 3, what does that mean? Remainder 3 means 2 to the power 3. So remainder is 3. This means 2 to the power 3, that is equal to 8. That is the answer. And that is what happened over here also, right? When the power cycle completes, it's at 6. After that, we have 3 extra. 1, 2, 3. That is where this line came in. That is why 8. Got it now? So whatever is the power divided by 4, get the remainder, and then the base value to the power the remainder. That is the answer. Now let's apply the same thing to 2 to the power 125. It's impossible for us to count till 125, obviously. It's not impossible, but it's stupid and time consuming. So let's not do that. So we have 125 divided by the same thing, 4. Again, why are we dividing by 4? Because 2's power cycle has 4 terms. So we divide it by 4. What is the remainder over here? 125 by 4, the remainder is 1. Okay, so what is the final answer? The final answer is 2 to the power 1, that is equal to 2. If you are really jobless and you really want to verify this, then please be my guest. Write down in your notebook 2 to the power 1 is 2, 4, 8, 6. Write down the power cycle and then count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 all the way till 125. I guarantee you will stop at 2. Okay, so this is the fastest way of doing it. Now, do you want to know a method in which I can reduce this time even further? Let's see. We have to divide the power by 4, right? Now, what if I tell you that we don't have to divide the entire power by 4? Yes, we don't have to actually. Let me tell you why. When it comes to divisibility rule of 4, what do you mean by divisibility rule? See, for example, what is the divisibility rule of 2? How do you know that a number is divisible by 2 without actually dividing it by 2? Any number which is an even number. This is an even number. This is divisible by 2. Do we need to actually divide it and check? No. We know that this is divisible by 2. Similarly, what is the divisibility rule of 3? Divisibility rule of 3 states that the sum of the digits should be a multiple of 3. For example, suppose we have the number 123. Is this number divisible by 3 or not? Without dividing, how do we get to know? We simply add the digits 1 plus 2 plus 3. 1 plus 2 plus 3 is 6. 6 is divisible by 3. That means 123 also is divisible by 3. Similarly, what do you think is the divisibility rule of 4? Divisibility rule of 4 states that we only check the last two digits of a number. For example, the number could be anything. The number could be 1, 2, 3, 4, 5, 6. How do we know that this number is divisible by 4 or not? The simplest way to do that is to check if the number by the last two digits is divisible by 4. We have the last two digits as 5 and 6, so 56. Is 56 divisible by 4? Yes, it is. If 56 is divisible by 4, then this entire number is divisible by 4. Okay, we know that 24 is divisible by 4. Yes, so anything can come before 27. Sorry, 24. It can be 9, 8, 7, 1, 2, 3, 9, 6, anything. We know that 24 is divisible by 4, so this entire number will be divisible by 4. You can take your phone number and end it with 24. That entire number will be divisible by 4 for sure. So that is the divisibility rule of 4. Okay. So since we are dividing 125 by 4, isn't it same as telling we have to just divide 25 by 4? Because we only care about the last two digits, right? Exactly. So instead of doing 125 by 4, you can simply do 25 by 4. And 25 by 4, what is the remainder? The remainder is again 1. It's the same remainder. That's it. So again 2 to the power 1, which is 2. So these three types of questions you will never be asked in any aptitude test. This was just warm up. Now this is the real type of question. We have 432 to the power 1, 2, 3, 4. Let's get to business. The first thing to do, the first way to reduce this question is, first of all, remove 4 and 3 because we don't care what comes before the units place over here. 2 is the units place of this number. That is all that we care about. So the first simplification step is 2 to the power 1, 2, 3, 4. Alright. So now what do? We have to divide this by 4. So we have 1, 2, 3, 4 divided by 4. And we just now learned that how to figure out if a number is divisible by 4. We simply divide the last two digits by 4. That's it. So 1234 can be reduced to 34 by 4. And 34 by 4, what is the remainder? We know 32 is divisible by 4. How many remaining? 2 remaining. The remainder is 2. That's it. 1, 2, 3, 4 got reduced to a mere number of 2. So the final answer is 2 to the power 2, which is equal to 4. Why this 2? This 2 is the base 2. And why this 2? This 2 is the power 2. And the answer is 4. So we have 2 over here, 8 over here, 2 over here, and 4 over here. Now let me ask you another basic question. What if when you divide the power by 4, the remainder ends up becoming 0? Then what do you do? For example, if at all you have a number which says 432 to the power 432. Now what to do? Now again 43 makes no use at all. So we have 2 to the power 432. Now 432 divided by 4, which is equivalent to 32 divided by 4. What is the remainder when you divide 32 by 4? The remainder is 0. So does that mean you have to do 2 to the power 0 that is equal to 1? No, 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 no. Absolutely not. 2 to the power anything other than 0 does need to end with 2 or 4 or 8 or 6. It has to end with one of these. So please understand, when the remainder is 0, that signifies that the cycle is complete. And which number completes the cycle of 2's powers? The number 6. So if at all the remainder is 0, that means the answer is 6. The cycle is complete. And this is for any number. Okay, be it 3, be it 7, be it 8, be it 4, be it 9, for any number. When the cycle is complete, we take the last term of the power cycle. That's it. That is all that it is. Now this was the basics of power cycles and cyclicity and units places. Alright, if at all you have any doubts in the basics, definitely go back to the cycles, the power cycles, and try to solve 1 or 2 questions by yourself. And of course, as usual, we have some extra questions over here as well. In this one, you have the base value as 2. In this one, you have the base value as 7. And in this one, we have the base value as 2 again. Please solve all of these 3. Try to solve it for the best of your abilities and drop your answers in the chat box. I have purposely not given any options over here so that you don't get distracted by the options. Get the perfect answers and drop them in the comment section. I'll let you know if you're right or wrong. Alright, that was the end of this video. This was purely for the basics of units places. I hope you liked this video, and I hope this video solved a lot of your doubts that you used to have in the past. If at all it did, then please drop a like on this video so that this video is saved in your liked video section of YouTube. And if at all you want to watch the previous video, it's right here. And the next video, that is part 2 of units place, is right here. If you're finding all these lesson videos helpful, then a subscribe would be amazing. Thank you so much once again. See you in the next video. Bye bye.